I'm going to do two things here. What I want to do is explore this unordered selections idea, but in two particular applications that maybe are a little less than obvious, okay? So here's my first one. Here's a scenario for you, and you've been asked ones like this in your exercises, but I just want to draw a nice corollary is what they call it out of it. Suppose you have 7 people, right? 7 people, and you want to choose 5 of them to be on a, I don't know, on a team, student representative council. You want to choose 5. Some people have been asking me, how can I tell, like apart from, oh, I'm in an exercise where this is what I'm supposed to be doing, how can I tell whether order matters or whether it doesn't matter? Is it a permutation or a combination? You have to pay close attention to language, basically. If I am picking a team, for instance, or a group, then picking, say, these 5, 1, 2, 3, 4, 5, does it matter which one's which? Well, no, there isn't a first or a second or a third or something like that. If I said to you, I'm picking a captain and a vice captain and etc. Now suddenly which one is which does matter, okay? But if I said 5 players are going to be chosen out of the 7, using our new notation, what would we say for this? What would be our way of calculating the answer? You'd say 7, C, 5. 7 options, choose 5 of them, okay? Now, what I want to call your mind back to, just like we did at the start of the lesson, is that we learned something about this from binomial theorem, okay? Namely that if you have a look at Pascal's triangle, okay, this is the same, 7C5 is equal to, because of the symmetry of Pascal's triangle, it's also equal to 7C2. Do you remember this? Okay. Now you can show this in a very easy way just on the definition, the factorial definition of what 7C5 is, right? And this is what you might want to write down. 7C5 is 7 factorial on what? What's on the denominator? What factorials are there? 2 factorial, 5 factorial, right? Whoops. There's the exclamation mark. But you can clearly see if you think about this guy, well, it's going to have the same numerator, and it's also going to have the same denominator, right? Except you just wrote it in a different order because you thought of it from a different angle, right? That's a definition, sorry, that's a proof from the factorial definition. But there is an even simpler, what we call a combinatoric proof, a way of thinking about the situation that tells you exactly the same information, right? I'm choosing 5 people to be on my team, right? Choosing 5 people to be on the team, can you see, is identical to choosing 2 players to be off the team. Does this make sense? Like choosing those 2 who are not on will give you exactly the same result as this. Again, the way we would say this in fancy mathematical terms is there is a 1-to-1 relation between the players who are off the team and the players who are on the team. You might as well have chosen 2 people and said, okay, let's just go home. I've got the 5 people that I want. You people can just go off. Okay, does that make sense? So this same idea which we met through Pascal's triangle and through the binomial coefficients, it's got a combinatoric reasoning underneath it as well. And often your ability to retell a problem, right, which is what I'm about to do over here, your ability to retell a problem can often change it from being quite complicated to being really simple. Okay? Now, can I ask all of you in your textbook, if you're not already in 10G, go there, and I'd like you to have a look at question 13 with me, because we're going to retell this in a particular way to show you how it's connected to all this unordered selections business, okay? So 10G, question 13. Arian, do you mind if I pinch back my iPad? Is that okay? Thank you. So, you can see it says here, 10 points are chosen in a plane, no 3 of which are collinear, which is a bit of a mouthful just on its own. So you can see what I've done here is I've drawn 10 points. They don't actually have to be here, obviously. They could be anywhere. But I've chosen these because it was just a bit easier to make sure that they would not be in a straight line, 3 of them, in any particular way. Okay? So that's why they're roughly circular. Now, there's a set of questions here, but the first one says, how many lines can be drawn through pairs, thank you, of the points? How many lines can be drawn through pairs of points, okay? Now, in order to try and work out what's happening here, let's give these points some names. Something that makes them easy to handle and talk about. Here are my 10 points, each of which is labeled. Now, give me an example of one of the lines that you could choose. Anyone? Any random? JD. JD, here it is. There's one of the lines, okay? Happy times. Give me another one. It's not that hard, really. You can pick any one you like. Sorry, say it again. B what? A, B, what? No. G, BG, BG, why not? BG, here we go, right across the other side. Okay? Just for the sake of completeness, give me one more. One more? CH, thank you. Okay, oh, there we go. That's very nice and convenient. Okay, now let me just repeat to you what you just said to me, I think. I think you said BG. No, I think you said JD first, didn't you? And then you said, what was the last one? CH. Okay, so this is what you told me, and then this is what I drew. Okay, now do you see, to create a line out of any 2 points on there, essentially what you have done is out of 10 possible letters, A, B, C, D, E, F, G, H, I, J, you chose 2 of them. Do you agree? This geometric problem is exactly the same as you have 10 letters. Choose 2 of them to make a 2-letter word. They are exactly the same problem, which is why their answers are also identical. Okay? So the way that you phrase this, the way that you tell the story, and the way you draw a picture, put it down, will define for you how exactly you answer the question. Now, I want to push on this. Why is it 10C2, for instance, and not 10P2? Why is it this and not this? What's the difference between them? The difference is order, whether order matters or not. So can you tell me now, why doesn't order matter in this situation? Nice and loud, Aaron, for everyone to hear.
JD equals DJ with the same line.
Okay, so if I vary the order, right? DJ and JD are the same line. I've drawn both of them, right? So therefore they are not really different. Order is unimportant. So now when you have a look at part B, that was part A, right? When you look at part B, I think it's asking you about triangles now, isn't it? Triangles? So here's a triangle for you. I'll just pick a couple of points here that haven't been used. There's a triangle. It's a bad triangle, but work with me. In order to create that triangle, what did I have to choose?
I, F, E, F.
Yeah, I, E, and F in this case. Did the order matter? No, you could just as easily have called it F, E, I. It would have been the same triangle, right? So in order to work out the number of triangles that I could form out of these 10 points, it's not going to be 10C2, it's going to be 10C3, because you just need 3 points. Any 3 points and they'll give you a triangle. By the way, that's why they make that weird statement at the beginning about them not being collinear. If there were some points that were collinear, you couldn't do this, could you? Because if you picked 3 points that were accidentally in a line, you're like, look, not much of a triangle, right? So that's why they put that condition there. So my suggestion to you, especially, I put it on the screen before, as you get to some of those later questions, it will not be obvious, what's the actual way you could tell the story to make it easy to use 10C this or 10C that, okay? So think about the way you can draw it, phrase it, write it down so it becomes a problem that you know how to solve, okay?